We're going to be looking at another initial value problem, only this time we're going to be starting with the second derivative. We'll be working our way up to the first derivative. It's the same thing as going from first derivative to the initial. Okay, we're doing this because we're about to look at motion problems which involve going from acceleration to velocity. Example number 2, if f double prime of x equals cosine of x and f prime of pi equals 2, then what is f prime of pi over 6? So again, we are given f double prime of x, which is cosine of x. It's a simple function. We are given that f prime of x is f prime of pi is equal to 2. We ultimately want to solve for what is f prime of pi over 6. So this pi over 6 right here, I'm just going to go ahead and label. This is actually your x value. Okay. So in this particular example, we are trying to solve for the y value. So let's go ahead and follow these steps, which, like I said, is basically the same as going from the first derivative to the original. We want to take the antiderivative because the antiderivative of the second derivative will give you the first derivative. And that's what we're ultimately trying to solve for. So antiderivative of f double prime is f prime plus c, don't forget that. Antiderivative of cosine is sine. Remember the derivative of sine is cosine, so the reverse is true. So therefore f prime of x equals sine of x plus c, and that completes step 1 of just taking the antiderivative. You're always going to do that when solving an initial value problem. Step 2 is to determine x and f prime of x from the point given. So x is equal to pi, and you can see that your y value is 2. So x is pi, f prime of x is 2. Now why are we determining this? Because we have to in order to figure out c. So step 3, plug in x and f prime of x values. So we're going to plug in 2 for f prime of x, and we're going to plug in pi for x. So I'll go ahead and just make a note of that right there with some different colors here. Red for x and blue for y, or f prime of x. Now we can just solve for c. And again, the reason we can do that is because they gave it to us in the initial problem. You basically have to have it or you won't be able to solve. Okay, now we're going to step 4, solve for c. Well, sine of pi is 0. That's because pi is 180 and the y value is 0 on the x-axis, and therefore c is just going to be equal to 2. So when you solve for c, that will ultimately allow you to solve for whatever you're trying to solve for. You have to solve for c first. Step 5, write the derivative equation with the known c value. So we're going to plug in 2 for c here. And now we have f prime of x equals sine of x plus 2. Again, you're given double the second derivative. You want to solve for something dealing with the first derivative. Step 6, plug in the given value in the problem. Could be x or f prime of x. In this case, they gave us that x was, let's see here, it says f prime of pi over 6. So we know x is pi over 6, so we just need to figure out whatever f prime is. So we're going to plug in pi over 6 wherever there is an x. In this case, there's actually just one x. All right, and then step 7 is to solve for the unknown. Now, sine of pi over 6, same as sine of 30, is 1/2. And then finally, f prime of pi over 6 is equal to 1/2 plus 2, which is equal to 2.5. And that's exactly what we're trying to solve for. So initial value problem, same going from second derivative to the first derivative as it is going from the first to the original. If you have any other questions about this example, let me know.